Good morning, everyone. I have a lot to cover today, so it's 9:40 on the dot, but I'm going to get started. My name is Jen. I'm a software engineering lead at Elsevier. I work in the precision medicine department, and in the healthcare field, we use testing not only to make sure that our features work, but also for auditing and compliance. So testing is very important to our process. Who here has heard of Tales from the Crypt? Okay, awesome, most people. Tales from the Crypt was a show from the 80s and 90s. This here is the Crypt Keeper, who was the host of the show. The show was actually based on comic books from the 50s and 60s, and I think they're really cool. So I'm going to show you some of the covers of those books today, while I tell you about some horror stories about QA and testing. And today I'm going to talk mostly about end-to-end testing, but some of the things that I talk about also apply to unit testing as well. So first up, our first horror story is about manual testing. I don't think I'm going to have to sell you much on this one, but let's just go through an exercise. So you have an email address input on your website. What do you have to do to test that this works properly? Here is some of the things that a QA tester might do to make sure that you can enter a valid email address so that you can collect users on your site. There's about 12 different things that you have to run through there, just a regular old email address containing dots, subdomains, various things like that. Then you also have to go through and make sure that you can't enter invalid email addresses because you don't want to incorrectly sign up and not be able to reach any users, and you want to alert the user if something is wrong. So add these all to your list of manual testing that you have to go in and manually type each of these in. So let's step back for a moment and talk about what a QA and developer relationship traditionally looks like. So I've worked on big teams and small teams. Sometimes you're lucky to have any QA at all. But typically, there's some developers that work on features, and then they report up to a QA lead. Or not report up, but they eventually send their features over to a QA lead who works with testers to test those features. Oftentimes, those testers are offshore testers, and the developers have no relationship with them whatsoever. And I've always thought that this divide between the developers and QA was kind of strange. I never really got to interact with those people, whether they were offshore or not. I might have had some conversations in Jira tickets and things like that, but other than that, there wasn't much interaction. So what happens when you have this type of setup is you get stuck in a repetitive workflow. The tester tests the feature. If they report a defect, that then goes up to the QA lead. They have to test it. Then it goes to the developer. They have to validate it before they can fix it. And if you're typing in an email address manually, that can get really annoying pretty quick. And then this cycle repeats itself because once the fix is put in, it has to be tested again, then go up to the QA lead and make sure everything is still working. So when you have a complicated form, such as a checkout process, testing this can get scary pretty quick. Luckily, JavaScript has had testing tools around for quite some time for automated testing. They all seem to have this common theme. I am not sure why. But one tool that I really like is called Cypress, and I'm going to do a demo of that for you today. Cypress is different than these other tools because it just comes with everything that you need out of the box. So you don't have to choose any frameworks, install Selenium, you don't have to do any of that. You just have to run one simple command, which is npm install Cypress. And then you can run npx Cypress open. So here is what a simple page load test might look like. You just load up a URL, and you want to make sure that a CSS selector exists on that page. So we're making sure that .app just is on the page. You don't have to worry about putting in weights or anything like that. Cypress handles it for you. So I made a little demo site to show you what Cypress actually looks like in person. So here we have a simple to-do list, the Crypt Keeper's to-dos. We all know how to-do lists work, so this is really simple. We can filter by active and complete. We can add one, mark it complete, and delete it. So here is what the Cypress tests look like for this app. And this is just a simple create React app with some Crypt Keeper style, and this is all on GitHub, and I'll share the link at the end of the presentation. But even if you haven't used Cypress before, I find this pretty readable. So we use Cy, short for Cypress. We get some CSS selectors. We type in Cypress test to do. We hit enter. Then we get list. @list is a saved variable that I've saved earlier in the file, which is just another CSS selector that gets that list. And we expect it to now have 4 items instead of 3. Pretty simple. So now let's actually run these tests and see what that looks like. Is that big enough for everyone to see? Hopefully, as I'm typing. So now we're running npx cypress open. And this is what the Cypress dashboard looks like. So we have 2 spec files in here. The example spec comes with Cypress out of the box when you install it, and it shows you the entire API. So it's a good starting point. I've skipped all those tests, but I've left them in the repo, just so you can take a look at them. And here we have the to-do spec that I wrote for our actual tests. I'm going to stop and restart so we can open the browser. And now we can watch Cypress going through each of the motions for each of our unit tests, or for each of our tests. And I think we have about 11 tests in total, and it takes about 14 seconds, so pretty quick. Imagine having to do all that manually. It would take you much more time. And you can also run this headlessly, which we will show later in the presentation. So in conclusion, Cypress makes your testing dead simple. Just one install. There's no, you don't have to set up any waiting. It has really good documentation. You can even set up different viewports to test responsive layouts. It's just cypress.io, and you can check that out after the presentation. So having all of these automated tests frees up your QA or your testers to do what they do best, which is find unexpected functionality on your site. You want to free them up from the boring, repetitive stuff like entering email addresses thousands of times so that they can find the more difficult and hard to catch cases. And when they do find those, hopefully they can write a Cypress test for it so that it's reproducible and you don't have to go through all of the strange, crazy steps that they might have. And that brings us to our next horror story, which is mystery tests. So back to that traditional QA workflow. Let's say you have this type of strategy where you develop, you go through code review. Once it's approved, it gets merged into whatever branch. And at this point is when it goes to testing. And this is a problem because by the time it gets back to the developer, context is lost. I call this the throwing it over the fence method because you develop your feature, you don't write any automated tests for it, and then you just move on to the next thing. And if there's a defect that comes back, then you just fix it later. Another part of the problem here is that if you have a totally separate testing team, sometimes they don't make those tests available to the actual developers. So you don't know what's being tested. You don't know how to access the tests or run them, and this is a problem. So how can we help with this? We can employ a strategy called shift testing left, which is exactly what it sounds like. You just move testing closer to development itself rather than sometime down the line. So instead of waiting for testing to happen after something gets merged into a different environment, you write your tests, and you have those tests before anything gets merged in. So this requires a little bit of coordination with testers and developers, but it's really not that hard to make it work. And testers tend to like having these automated ways of doing things because it frees up more of their time. And as a developer, if you're working with a QA team that hasn't actually written code before, you can help get them started by writing some of the simple tests, and they can pick up where you left off. But hold on. How's this going to work? Isn't this approach going to take a lot longer? How are we going to release on time? These are some of the questions that I hear when I bring this approach up? Well, let's take a look at this example. I got this from the Microsoft's blog, which is a pretty great diagram. So you have feature 1 and 2. They end up taking more time than expected. You get into a little bit of merge conflict hell. And that leaves QA with less time to test everything than they had hoped for. So they do some tests, you get in a couple fixes, but you release to production, and then you find much more defects later. So you put in another round of fixes, or hot fixes, and go from there. When you shift the testing left, you're not actually wasting a lot of time. You're just moving everything to the left. So while it will take some time to get used to a new process, once you're in the new process, it shouldn't really take any more time than this. You can still release with defects, but at least you're conscious of it, and you can choose which ones you want to do. Which brings us to our next horror story, which is unable to reproduce, AKA it works on my machine. This might be the worst one of all, and I think we've all been there. So how does this happen? Requirements are unclear, incorrect. The steps to reproduce don't include everything you need. Sometimes your work wasn't even in the environment that the tester was testing on, especially if you have many environments and there's one QA lead that's trying to manage various different testers and different features. It can happen. It ends up wasting a lot of people's time because there was no defect to begin with. And there's environment disparity. So different dependencies in different environments, different user settings, and environment-specific changes like production versus development. So if you're writing a single-page app, you tend to develop locally with a node server, but you probably are deploying static files to production. That in itself is a difference that can cause some issues. But we've actually fixed a bunch of these things already when we use our shift testing left approach. So the tests actually act as our requirements. And if they're on the branch before it gets merged, then we don't have this problem anymore. And if we're working on the same branch, the testers and the developers, then we know exactly which environment we're testing in. But we still have this issue of environment disparity. So how do we go about fixing that? For that, we're going to dive into containers, specifically Docker containers. So containers are small and lightweight compared to traditional VMs. They might be tens of megs, whereas a VM could be tens of gigs. They're easy to configure. All of their configuration stays in a YAML file in your source code. And they're open source, so anyone can use them. There's no license fees. So let's go back to our demo and see how we can run that demo inside of a Docker container. So first, I'm going to shut down the server that I had running. And let's take a look at a simple Docker Compose file. So Docker Compose is used to tie together different services in Docker. We only have one service here, but it's a lot simpler to lay all this out and show you in the demo, and we're going to tie some services together later. So we're going to start with this. So going through this file, version 3.4, that is just the version of Docker Compose itself. And then we have our services. So I have a service called UI, and you can call these whatever you want. Then I have a build declaration, and this is where you specify the Docker file that you want to use. So I just have, by default, it knows to look for a file called Dockerfile, and here is our Docker file. And we're targeting dev. So we have 3 stages in this Docker file. We have a dev stage, a build stage, and a prod stage. By targeting the dev stage, when the Docker container runs, it's going to stop right there and not go to any of the other stages. So let's go through this a little bit. So we're pulling from the node 10 image. Docker has a registry of images, similar to how NPM is a registry for modules. There's a registry of images. So we're pulling in node 10. We're calling that our dev stage. And then we're going to set a working directory inside the container. We're going to call that app. You can also call this whatever you want. Just because we don't want to mess with all of the files or anything in the root of the container itself, we're going to do everything inside of the app folder. We're going to copy in package.json, and then we're going to run npm install. And you might notice I'm running npm install production here. I'm only doing that because to run our development site, I don't want to install Cypress. I only want to install Cypress when I'm running the tests. So I put Cypress as a dev dependency. And I only need my other dependencies to install via the production flag to run the site. So if we go back to our Docker Compose file, next we're going to map some ports. So I am going to map port 3333 on my host machine to port 3000 in the container. Because when npm start runs in the container, it's going to start the site on port 3000. I could easily map this to port 3000 on my local machine, but just for illustration purposes, we'll look at it on port 3333. And I also have a mock API running at port 3001. Next, we're going to mount some volumes in the container. So I'm just mounting in all of the files that I need to run the site in development. And then we just run npm start. So in order to run this, you just do docker compose up. By default, it will look for a docker compose file. You can specify other files as well by passing just a different flag. And that's it. So we can see that our mock API started, and our development server started. And in the container, we're running at localhost 3000, but remember I mapped that to port 3333. So I should not be able to access the site at 3000 anymore, but if I go to 3333, everything's up and running. So this is great if you have new team members starting and you want to get them up and running quickly. You can just give them one Docker command, and they're good to go. Do I develop inside of Docker locally on my normal machine? I don't. It's just faster not to. But it's a good option if you want to try different things out, like trying a different node version or other dependency versions that you want to just throw up real quick. All right, so we've got our local site, our local dev site running. Now, how could we run our production site on our local machine? So for that, we can just set up a different type of Docker Compose file. And I'm going to call this one dockercompose.nginx, because that is, nginx is what we're using to serve our files in production. So this is pretty simple. Again, we only have one service. We're building from that default Docker file, but our target this time is prod. And we're going to map port 80 in the container to port 4000 on our local machine. So if we go back to our Docker file, once we get past the dev stage, now we want to run our build. So we inherit the dev stage as our build stage. We copy in some files, and then we just do npm run build. Next, we actually pull from the nginx image. So we're not actually starting with node or anything else. This image will just have nginx. We're going to copy in our nginx config file. And then from the build stage, we're going to copy in the build folder into our nginx container. And our nginx config file is pretty simple. We can take a look at it real quick. All we're doing is, rerouting everything to index so that React can handle the routing. So if you've ever had to make nginx config changes before Docker, you probably know what a pain it is to set that all up on your local machine for the first time. This makes it much, much simpler. So in order to run this Docker Compose file, we're going to pass the F flag, and then just specify the name of the Docker Compose file and run up. And it's done. So now if I go to port 4000, there we go. Notice we weren't running our mock database, so that's why our to-dos don't show up anymore, since this is our production site. And now, the first time that you run Docker Compose up, it's going to pull all of the images and everything that you need. So it will take, I don't know, depending on how many dependencies you have, it might take a little while to start. But subsequent runs will be just as fast as I showed because everything is cached inside the layers of the container. However, if you ever want to rebuild anything that is already in a Docker container, you can just pass the -- build flag. And as you can see, it's going to use everything that it can from cache unless it detects any file changes. And since we didn't make any file changes, this was really fast. But there's one more scenario that we have to figure out. And that is how are we going to run our tests in CI and then replicate that on our local machine. So for that, we're going to tie some services together. So here we have a docker compose.test file, and we've got two services in here. One is called tests, one is called Nginx. And then we have a network set up between the two. So our Nginx service is exactly like what we just looked at, except we've added a network and set up an IP address for it. And we've also turned the logging off because I just want the test output. I don't really want to see any of the Nginx logging itself. And next, our tests service. Here we're going to specify a different Docker file. And we're going to tell it that this service depends on the Nginx service. And it also links to it so that these networks can talk to each other. And depends on can be a little tricky. So that just means that it's going to wait for that service to start. It's not going to wait for any commands to actually run in the container itself. It's just going to wait for that thing to start up. And next, we have some environment variables that we're setting. So we're setting CI to true. We're going to change our Cypress base URL, so the site that Cypress is going to visit, to the IP address of the Nginx service that's listed down here. And we're going to set video recording to false, because I just don't feel like saving videos here, and maybe it'll save some time. And then we are going to mount our Cypress files into the container so that we can make changes to those on the fly if we want to. And then we just do npx cypress run. So let's see what this looks like. So again, we're going to do docker compose and pass the F flag and specify our tests file and run up. So our Nginx container has started. We get a nice little warning that we're not logging anything. And now we have Cypress starting. So these are the example spec tests that I showed you that are all skipped. And now our to-do app tests are starting. Great, everything passed. And we have an exit code of 0, which means everything is good. And you can also pass a flag to automatically grab that exit code so that the containers will automatically shut down and give you the exit code, which is typically what you want in CI. And all of these commands are listed in the README, in the repo, so you don't have to remember them. And this one contains the exit code from flag. So let's recap a little bit about what we talked about. We talked about making some changes to your tooling to make sure that you can write automated tests easily. We talked about changing your workflow to include testing closer to development. And we also talked about updating your infrastructure to use things like Docker to make sure that things are reproducible. But more importantly, it's better to make sure that you see eye to eye with your team. If you're going to make any of these changes, you can do it incrementally, and you don't have to do it in the order that I listed. But make sure that everybody's on board with writing automated tests, that they like the tools that they're using. If you already have a large test suite that's not in Cypress and that's working for you, then great, continue to use that. But make sure that those tests are available to everyone and that anybody can run them whenever they want. Keep it as close to development as possible. Use Docker for environment parity, and adjust it as needed for your team. Thank you very much. Here is the repo. Reach out to me on Twitter if you have any questions. I'll also be here all day today. And if you're interested in working at Elsevier, come chat with me as well. Thank you very much.